Let me tell you why you're here. You're here because you know something. What you know you can't explain, but you feel it. You felt it your entire life, that there's something wrong with the world. You don't know what it is, but it's there, like a splinter in your mind, driving you mad. It is this feeling that has brought you to me. Do you know what I'm talking about? Do you want to know what it is? Remember, all I'm offering is the truth, nothing more.
And a very warm welcome if you just joined me on my channel, Nigel View on Things. How you doing? How you keeping? Hope everybody's safe and sound where you are. Mekoryuk SouthWest. Okay. Monday, 4th of September 2017. The sun's overhead. You know, it looks really dark to me, but hey, who am I to say? I'm looking at the sun coming through the sky here, and I notice that we've got our lensing system. Don't try and tell me that there isn't something in front of the sun. I'm showing you pictures that it's just proof that there is something there. You know, it actually looks like a cartoon coming through the sky. These are not camera abnormalities. This is the petal system. I've shown this many times, and you've got this, what I would consider to be an LED light. I'm going to stop it there, and you can see the lensing system right in front of you. There it is. It's big, it's round, and it's, yeah, and it's more prevalent now than ever. And you can see the petal system there and through there, and we got a lens flare just here. You know, there's nothing wrong with that at all. I haven't applied any filters in any way, shape or form. That's exactly what you're seeing is what I'm picking up. And you can see there's a lens, projection of a lens just there. Nothing wrong with that at all, is there? You know, and it's again and again on every single camera. And the sun sets into a glorious ball of explosion as it normally does on the horizon, as you can see just there. Every day, every night, it's red. Sunrise is red, the sunsets is red, there's a red tinge to the sky. Yep, nothing wrong at all, I'm just saying. Any rates, we're looking at Hooper Bay. Look at this sun here. Is that the sun that I remember when I was a kid? No, it's definitely not. You know, it looks like an LED torch in the sky. Come on folks, and what's all this about? You know, this is being projected onto the lensing system of the camera. You know, pictures every 10 minutes, links to everything in the box down below, and you can see the lens system just round the outside there. You know, it just stands out like a sore thumb, and all of a sudden, yeah, what just happened there? You know, we've got the lenses round the outside, and this is absolutely normal, and you can see that the sun has now disappeared. Like I said, each picture is 10 minutes, so 10 minutes has gone past, another 10 minutes has gone past, and what just happened there? That is just a total impossibility. But yet again, there is absolutely nothing wrong. Hooper Bay West, Monday, 4th of September 2017. And you're going to tell me there is nothing in our skies. These are all lens flares. I'm looking at this here, and I know this is a lensing system every time I see this now, and we'll have an explosion of light coming onto the camera very shortly. But something very interesting appears, and I'm going to stop it there, and it is this object here. This is over here somewhere, but then something else happens. And just there, our red spinning planet. You've got the lensing system round the outside. I mean, come on, really? Should it be on camera? No, it should be on camera. It can't all be lens flares, folks. That's all I've got to say, really. Big explosion in the sky. Okay, Selawik SouthWest. Monday 4th of September 2017. You can see the lensing system around the outside here. It's, you know, it just looks like a cartoon, and yet chemtrails in the background. And the sun simulator is going through the sky. The sun is still there, by the way, folks. You can see the chemtrails flying through the sky. The nice bits of poison that they're, yeah, we've got to breathe that in, folks. You know what I mean? Don't worry about us. Selawik West, Monday 4th of September 2017. But you try and tell me what we're looking at here. This is the backwards lit planet that I've caught many times, and I know this is projection because it is the wrong way around. They're using mirrors and lenses and everything. I made a video about it. I'll leave the link in the description box down below so you can peruse to your content. Try and tell me that, you know, that's the moon. Of course it is, yeah, because it's backwards lit, of course, yeah. And we get this big explosion of light in the background. Lensing, oh yes, most definitely. I must apologise about the wind now. I shut the door. Hope everything's a little bit better. Still miling, but yeah, we've had continuous winds for the last 2 months. It just reminds me of April. That's what my mum said to me when I saw her the other day. Before I show you these pictures, I would like to explain how a thermal imaging camera works. I know it says how night vision works up there, but we're talking about thermal imaging. Here's how thermal imaging works. Number one, a special lens focuses the infrared light emitted by all objects in view. Basically what it's saying is that everything has its own heat signature. That's the best way of describing it. The focus light is scanned by a phased array of infrared detector elements. The detector elements create a very detailed temperature pattern called thermogram. It only takes about 1/13 of a second for the detector array to obtain temperatures information to make the thermogram. This information is obtained from several thousand points in the field of the view of the detector array. That was easy for me to say. Number three, thermogram created by the detector element is translated into an electronic impulse. And by the way, you cannot see through glass with a thermal imaging camera. All you get is a reflection. Number four, the impulses are sent to a signal processing unit, a circuit board with a dedicated chip that translates the information from elements into data for the display. Number five, the signal processing unit sends the information to the display where it appears as various colours depending on the intensity of the infrared emissions. The combination of all the impulses from all the elements creates the image. Most thermal imaging devices scan at a rate of 30 times per second, and that depends on how good the thermal camera is. Some of them are right down to 14 times per second. They can sense temperatures ranging from -4 degrees Fahrenheit to -20 degrees Celsius to 3600 Fahrenheit, which is 2000 Celsius, and can normally detect changes in temperature of about 0.4 of a Fahrenheit, which is 0.2 of a centigrade. There are two common types of thermal imaging devices. Uncooled, this is the most common type thermal imaging device, and this is what I've got. The infrared detector elements are contained in a unit that operates at room temperature. This type of system is completely quiet and activates immediately and has a battery built right in. Then we have a cryogenically cooled, more expensive and more susceptible to damage from rugged use. These systems have an element sealed inside a container that cools them to below 32 Fahrenheit, 0 Celsius. The advantage of such systems is the incredible resolution and sensitivity that results from cooling the elements. Cryogenically cooled systems that can see a difference as small as 0.2 Fahrenheit, which is 1 Celsius. From more than 1,000 feet, which is 300 meters away, which is enough to tell if a person is holding a gun at that distance. Let me show you a couple of images so I can explain what's going on so you get the idea. Let's have a look at the camera. It's 240 by 320, the width is 240 pixels, height is 320, and the bit depth is 24, and it produces a PNG image, as you can see there. We've got a handprint on the wall, or two handprints on the wall, 19 degrees. You can see the truck here, it's black, that means it's hot. Where it's white, it means it's cold. Sky there is minus 18 degrees, and basically we're not getting a image in the true sense of the word, we're getting an image that's built up, yet again, from infrared signatures. That's the best way of describing it. The whiter is the hotter, and the darker is the cooler, as you can see. I tried to work out where my dog had been sleeping, and it's not very obvious in this picture, but when we have a look in this picture, you can see she's been sleeping on the sofa. Bless her little socks, eh? This is an LED light bulb, by the way, 316 degrees Fahrenheit. You can see the picture of the kettle there. Let's have a look at another picture of the kettle, and you can see the whiter it is, the hotter it becomes, and you can see how hot the lead is and the reflection on the side, and you can see it in a different filter. Yet again, the whiter the hotter, and you can see how hot that lead actually gets, and you get the reflection of the work surface just there. These are some objects in a black plastic bag. You can see through black plastic bags, but you can't see through like a CD, or it can't see through glass that just reflects all the different bits and pieces. Here's the same image but under a different filter. Yet again, handprints on the car, and you can see the reflections of me and Dan. Hello Dan, by the way. So when I take pictures of the sun, I expect to see the sun and nothing else really. The reason we got this is because I've actually moved the unit. Let's have a look at the details on this picture. And as you can see, it was taken on the 16th of the 6th, 2017 at 8:35 AM in the morning. And you can clearly see there's something around the outside. Yet again, exactly the same, different type filter. That shouldn't exist because our sun is round and it's not a triangle. That tells me that. So don't forget, this is not a picture, this is a thermal image. So to get a picture like this, well, what can I say? And you can clearly see that there's different, we've got our sun and we've got something around the outside. We shouldn't be getting that, not on thermal. That means to me that there's actually something there. And you can clearly see the whiter it is, the hotter it is, and we've got a cooling effect that's going on around the outside. But there's absolutely nothing wrong. There's nothing in front of the sun, of course there's not, you know. You can see the reflection of the clouds and all the other bits and pieces, but we should not get this around the outside. Let's have a look at the details on this picture. It's the 29th of the 8th, 2017 at 6:49 in the morning. The ambient temperature, or the temperature where I'm pointing the thermal imaging device on the floor, is 57 degrees Fahrenheit, and you can clearly see around the outside there is something a little bit amiss here. Run it through different filters, you can clearly see that there's something in front of our sun. And it becomes more obvious as we go through the pictures. You can see that I've zoomed in here, it's times 1.9 at the bottom. Really, all it should be doing is reflecting the sun back. We should not have this object around the outside. So what we're going to do is measure the temperature. As you can see here, it's 165 degrees Fahrenheit, 268 degrees Fahrenheit, 259 degrees Fahrenheit, 232 degrees Fahrenheit, 181 degrees Fahrenheit, and that is the temperature of our sun, 181 degrees. Come on, really people? And this picture here, let's have a look at the details. And the time taken is 13 minutes past 7. Same day, 29th of the 8th, 2017. But we can clearly see that this is going through the cloud here, and it just doesn't look the same as it did. And now you can see that the clouds have gone, and the time now is 7:25. Ambient temperature is 63 degrees. That's on the floor possibly, but we still got this big ring round the outside. Yeah, that's normal, isn't it? You know, that is just so normal. So you've got to ask yourself, what have they put in front of the sun? There's nothing there. Of course, the thermal camera has a bug. That's a lens flare. And let's have a look at the time of this picture. 7:27, 29th of the 8th, 2017. 559 degrees. That's the best temperature I managed to get. I didn't get no further than that. And basically it's like somebody's just turned the sun on. But the sun is always on. It's constantly hot. For me, this means that there's something wrong. Let's be logical about what we're looking at here. This picture here was taken at 6:53. And we'll click through the pictures. And this last picture was taken at 7:30. So what you're trying to tell me, the sun has increased in temperature in 37 minutes. The only way this can happen is if there's something in front of the sun, that in itself is starting to warm up. And that is what we're producing here. If I point my thermal imaging camera at the sun, it should produce an error that it's too hot. You shouldn't be able to actually read the temperature of the sun. You still don't believe? Let me show you just one more bit of proof. I would like to thank a subscriber for sharing these pictures with me. I don't know if they want to remain private. If you would like credit for what I'm showing, please let me know. You know exactly who you are, and I will give you credit. Thank you very much for sending me these pictures. Cape Yakutan East. I'm going to play these backwards. Monday, the 11th of September 2017. And let's just click through the photos. First of all, you can see there's an obfuscation of light, as we always seem to get now. Lensing system straight on there. And as we click through, our sun is coming down, but actually what it's doing is rising. And for me, these pictures actually prove exactly what I'm saying without any reasonable doubt in any way, shape or form. And that's how our sun looks. Of course, it's a big orange ball in the sky. There's something missing from this picture, because that is why it's like a big LED torch. And you can see the sun. You can see exactly what actually happens when the sun goes through the chemtrails just there. And as the sun goes through the chemtrails, you can see how it distorts, and that's exactly what it's meant to do. Anything behind it, in front of it, or whatever. We've got a part of a lens flare popping up there, and let's flick through the pictures. You can see that there's something just here, and what a strange lens flare we've got there. Ooh, yeah. Nothing to see here. There's no lenses in front of the sun, of course there's not. And we can see the actual reflection of this lens system just here as this lens lights up like a Christmas tree just here. This to me proves exactly what we've just been talking about with the thermograms that we just had a look at, or pictures or whatever you like. There is nothing wrong with our sun. Really? Are you sure about that? They're not hiding absolutely anything, are they? And for me, this is 100% proof. If you don't find that there's something wrong with what we've just been looking at here, you've got to be crazier than me, and I'm crazy. What you got to remember, there are no lens systems, there is no sun simulator, there is absolutely nothing wrong. There's nothing wrong with the skies, there's nothing wrong with our water, there's nothing wrong with the food, there's nothing wrong with the weather. Shall I carry on? Because everything is very, very wrong. That's all I've got for you now. Much love, much peace. Catch you next time.